Before looking at example 3, let's look up above at the find or rule key concept information. A sequence can also be shown in a table. The table gives both the position of each term in the list and the value of the term. So if the list was given here as 8, 16, 24, 32, and so on, okay, I can put that in a table and give you the position. So the first term is 8, the second term, the value of that is 16, the third term, the value is 24, and the fourth term has a value of 32. So I can write an algebraic expression to describe a sequence, and the value of each term can be described as a function of its position in the sequence. So that means the position, how do I get from the position of the number to the value of the term? So it's basically like making an input-output table like we saw in lesson 1. So how do I get from the position to the value of the term? So we're going to see that here in example 3. So I'm no longer going from term to term, but from the position to the value of the term. Let's look below at example 3. Use words and symbols to describe the value of each term as a function of its position. Then find the value of the 10th term. So I can see in the table below the value of the term in position 1 is 3, the second positioned term is 6, the third position term is 9, the fourth position term is 12, and then they have n there to represent any position term. I could find the value by doing what? So they've kind of then created this into an input-output table that we saw in lesson 1, with the position being the input and the value of the term being the output, and then putting the function rule here in the center of multiplying by 3, because that's how they figured out the relationship between the position and the value of the term. So you can see that here, that to get from 1 to 3 I multiply by 3, to get from 2 to 6 I multiply by 3, and that continues for all of the other values. So if I'm figuring this out, okay, I would then say for my nth term, okay, or any valued term, okay, or any positioned term, I would do the position times 3, or its general rule would be 3 times n, or 3 times the position of the term. So the value of the 10th term, so that's if my position was 10, like the question asks, I would do 10 times 3, which would give me 30 as the value of the 10th term. So the idea here is realizing this rule, this function rule that applies here. I can figure out the 100th term of this list pretty easily by just doing 100 times 3 to figure out that the value of that term would be 300, and I don't have to sit here and list out all of my terms.